Everyone, welcome again. Last video we have seen about problems on Lami's theorem. Now we are going to see one more problem in Lami's theorem and its application. In this problem we have a little bit of keyword twist and little bit of twist in this diagram. Okay, so how to solve the problem we are going to see now. Okay, so let us go to the problem now. A rope attached to two weights as shown in the figure. Find the tensions in each end and also the unknown weight. So while focusing about the diagram, this diagram always in this previous video we have already used the same diagram, but here we have some minor changes. So what are the changes we need to see? They have given the distance between the ropes. They have given the angular distance, and they have given one weight as the value 200 Newton, another weight that is unknown. Okay, so we have to find this unknown weight as well as tension in the cables in this end. We have to find the tension in this end and those ends. So these are the values we must find before. After that, you can see, you can compare with the previous problem. They have given the alternative distances. So the given distance is 120, this distance is 60. Here the distance between the two ends is 40 and the distance between the two ends are 20. So this is the given distance. But you can you can notice there is no degree found. Okay, because in terms of Lami's problem, they will always give the degree, but in this problem they didn't give the angular distance, angular degree. So what you have to do now? First you have to find the angular distance or angular theta. So I am taking this angular distance as theta 1 and I am taking this angular distance as theta 2. So theta 1 and theta 2, those things must be found predominantly. We have to find the values of theta 1 theta 2 first. After that we need to go to the problem. Okay, so how to find the value of theta and theta 2? We have the following steps. So what do you mean by a theta? What do you mean by sin theta? It is defined as the distance between the ratio of opposite distance divided by hypotenuse, right? So if this is the triangle and this is the theta angle, means the value opposite to the theta, the value opposite to the slant edge is called as opposite, and the value in which the line slides is called as hypotenuse, and the base side is called as adjacent. So this is opposite, this is hypotenuse, and this is adjacent. Okay, so compare the values of the two blocks. First of all, I need to take these values like this. This is 40 and this is 45. The degree is placed here, theta. So the value opposite to theta 1 is 40. The value hypotenuse to theta 1 is 45. That is why the value of theta 1, which is equal to sine inverse of 40 divided by 45, which is nothing but 60 degrees. After that, while comparing the second block, this will be the degree. This is the value of 20 and this value is 30. The degree is being placed here. Okay. The value theta 2 is opposite to 20 degree, 20 mm. The value opposite to hypotenuse value is 30. So theta, which is equal to sine inverse of 20 divided by 30, which is nothing but 40 degrees. Okay. In terms of degrees, in terms of units, they will not give any unit because all the dimensions are in mm. So they won't give whether it is millimeter, whether it is centimeter or decameter or meter, because usually you used to practice without they have giving anything, means we have to consider all dimensions are in mm. So we will go to the video now. Already we have found the value of theta 1 60, theta 2 as 40, right? So we have to separate this into two blocks. While splitting into two blocks, the first point is here. This is your first point. From this first point, we have three lines diverging. This is number 1, this is number 2, and this is number 3. So that is why from this point we can get the values of this T1, and this value is called as T2, and this line is called as W1. Already they have given the value of W1 as 200 newtons. Okay, we don't know the value of T1, we don't know the value of T2 as well. So what we have having is we have theta 1. After that, after theta 1, we have a constant value of 90 degree. So we have to add the value of 90 with that theta. From that sine inverse conversion, we got the value of theta 1 equal to 60 degree. So we have to add 90 plus 60 which is equal to 150 degrees. We have 150. The constant distance between T2 and W1 may be taken as 90 because there will be no deviation. There is no deviation, right? So you have to take it as 90 degree automatically. We have 150, we have 90. So the total degree 360 minus 150 plus 90 which is equal to 240 which is being 120 degrees. The remaining degree will be 120 degree. Okay, so apply the Lami's theorem with respect to those things. After that, separate into second block. For this second block, this is the common point. From that we have three lines splitting. So the first line is being T3 and the second line is being T2 and the third line is being W. In this value, we have already found we don't have T2, we don't have the value of T3, but also we don't also have the value of W. All the three values are unknown. We are also not having the degrees. How to find the degrees first? We have this theta 2 here. This is your theta 2, right? We have found the theta 2 value from sine inverse value, that is 40. If you apply theta 2 equal to 40, 90 plus 40 which is equal to 130 degree. So the total degree is being 130 degree. After that, the distance, angular distance between T2 and W is being 90. So the values are 130 plus 90 which is equal to 220 degrees. We have to subtract it from 4 or 360 degree which will be equal to 140 degrees. So we have the common angular distances like 130 degree is found, 90 degree is found. By subtracting with 360 degree, we will get the value of 140 degree is also. We have 140. So for both the blocks, we have all the three sine waves, all the three angular distances we have found out. So we have to apply it by applying Lami's theorem. How to apply Lami's theorem? For considering first block, if you consider T1, the opposite sine angle distance is being 90 degree. So T1 divided by this sine 90. After that, T2, you have to consider T2. The opposite value of T2 is between T1, not T1, W1. Between T1 and W1 is 120 degrees. So the value is T2 divided by sine 120. After that, W1 divided by not T1, not T2. The difference between T1 and T2 is 150 degrees square. So that is W1 divided by sine 150. So we have to apply the values. The value of sine 90 is nothing but 1. The value of sine 120 is 0.86 and the value of sine 150 is 0.5. Also, we have W1, the value of W1 equal to 200 Newton, that has been given in the problem. So applying those stuff, T1 divided by 1, T2 divided by 0.866, 200 divided by 0.5. At the first step, T1 which will equal to this one multiplied with the 200 divided by 0.5. So the value is being 400 Newton. After that, T2 divided by 0.6 and 200 divided by 5 can be equated. If you equate things, this 0.86 will be multiplied with the value of 200 divided by 0.5. So 200 divided by 0.5 into this 0.866 multiplied with this value and we can find the value of 346 newtons. After that, while considering block number 3, the value of T2 has been found out because we have already found the value of T2 as 346 newton. So we cannot touch. So we can leave this. The remaining problems are T3 is remaining, W is remaining. So apply the value of T2. The value of T2 already found 346. Apply this 346, the value of sine 40. How the sine 140 came means T2, the opposite sine angle is 140 degree. After that, the value of T3, that opposite sine angle is 90 degree, sine 90. After that, W, that opposite sine angle is 130 degree. So W divided by sine 130. The value of sine 140 is 0.64. The value of sine 90 is 1. The value of sine 130 is 0.76. So whatever the unknowns we could find means T3 is unknown, W is unknown. So we have to equate this 346 divided by 0.6 value with the respective equations. How means? First equate T3 with the 346 value. T3 which is equal to, then 1 is multiplied with 346 into 0.64. By multiplying the value, we can get 540 Newton. After that, by applying W by 0.76 with 346 into 0.5. So this 0.76 value will be multiplied with this 346 divided by 0.64 into 0.76. The value will be found as 410 Newton. So from that we can find the value of, we can write the results now. The found given results are T1, T2, T3 and the unknown weight W. So what are the values? We have found the values of T1 as 400 Newton, the value of T2 346 Newton, the value of T3 540 Newton, and finally the value of W is being 410 Newton. By this way we can apply Lami's theorem problem in an alternative way. So, and I need to say something new, because this is also not the end, because in this Lami's problem we have variety of scope, we have variety of ways, variety of probable ways to ask the questions. We have lot of possible questions to ask. Either we can cut the value of 200 Newton, we can keep it as W1 and W2. We need to find both the values of unknown weights. Lot of problems will be asked like this. So these are the problems I can probably get you. In the upcoming videos, we will discuss about resolution of forces and Lami's theorem problem in a brief manner. Okay. So please share the content, like the content, and comment in the comment box if any comments arising or any doubts arising. Thank you.